Bright Tuty. Every student matters.
Okay, so for 81, let's just think about one factor of 81, and I see that it is 9. Okay, what is factor of 9 then? It is 3. Okay, so is 81 divisible by 3 as well? Yes. We can, try it for some other number. Suppose I take 18, okay, and one of the factor of 18 is 6. 6 is also divisible by 3. Okay, 6 factor is 3, also 6 factor is 2 as well. So is 18 divisible by 3 and 2 both? Yes. So what actually we can say, you can try this for different numbers. If there is a number, it is divisible by another number. It will also be divisible by all the factors of that number. Like 81 is divisible by 9 because 9 is a factor of 18. 81 is divisible by 9 because 9 is a factor of 81. Similarly, factors of 9, if I calculate, those will be 1, 3, and 9. Okay, now all three of them will definitely divide 81 exactly. So what we say, if a number is divisible by one of its factor, then it is also divisible by all the factors of that particular number. So the result is this. If a number is divisible by another number, like 81 is divisible by 9, then it is also divisible by each of the factors of that number. That means this 81 will be divisible by all the factors of 3. In case I see here, 18 is divisible by 6. So 18 will also be divisible by all the factors of 6 that we have. Clear? Okay. Now, going to the second divisibility rule that we are going to discuss is, okay, now you need to consider the number. Suppose we take 80. Okay. So if I take 80, is it divisible by 4 and 5 both? Do you think? Yes, 4 exactly divides 80. 5 also divides exactly 80. Now, if I multiply 4 and 5, what do I get? 20. Will 20 divide 80? Yes, for sure it will divide it. Okay, 80 is exactly divisible by 20. Similarly, let's take one more number, and you can see 4 and 5 here are co-primes. Okay, 60 if I say, okay, 60 is divisible by 3 as well as 5. Okay, and it is also divisible by the product of 3 and 5, that is going to be 15, right? So what is the result that we can say, that if a number is divisible by two co-prime numbers, okay, like 4 and 5, so it will also be divisible by the product of that. So the result is here. If a number is divisible by two co-prime numbers, then it is divisible by their product also. Clear? Moving ahead, now let us now see another number and find out what else we can have. Suppose the numbers 16 and 20. Okay, these are the two numbers. Are they divisible with 4? Yes, this is exactly divisible by 4. This is also exactly divisible by. Now you add these two numbers. 16 plus 20 gives me 36. Is 36 divisible by 4? Yes. So you can try it for some other numbers. We can take the examples. Suppose I say 15 is there. Okay, let us write them. I'm taking one more example to prove this. You can take multiple examples. So suppose I have 15, that is the one number. Suppose I have 35, that is the another number. Now 15 is divisible by 5. Okay, or I can say 35 is also divisible by 5. Let's just add them. 15 plus 35. So 5 and 5 is 10, 3 and 1 4 and 1 5, we get 50. Is 50 divisible by 5? Yes. So what is the result, student? We can say if two given numbers are divisible by a number, then their sum is also divisible by that number. This will always happen if you have two numbers and they are exactly divisible by some number. You add them and try to divide with that number. They will always be divisible. Same goes with the subtraction of the numbers. Let's just do that also by taking one example. Let's take 35 and 20. Okay, are they both divisible with 5? Yes, they both are divisible with 5. Take the difference of 35 and 20. So if you take the difference, let's just write that 35 minus 20. So the result is 15. Is 15 divisible by 5? Yes, it is divisible by 5. Exactly divisible by 5. 35 is divisible by 5. 20 is divisible by 5. That means if we have a number, if we have two given numbers and they are divisible with some number, then their difference is also going to be divisible by that number. So this is the result. If two given numbers are there, divisible by some particular number, then the difference will also be divisible by that number. After this, students, after these four results, we are going to discuss one very important concept, that is, so now we are going to discuss prime factorization. What is prime factorization? As the number or the name says, it is going to be, it will include prime numbers. Factorization means, just see, 16, if I write it as the product of its factors, like I can write it as 4 into 4, I can write it as 2 into 8. Okay, so like this, when I write, I say that I have written, or 16 is factorized. It is just known as the factorization of 16. When it comes to prime factorization of 16, in that case, how do we do? I just have to include the prime factors. Can I convert this 8 as prime factors, as the product of prime factors? Yes, 8 can be written as 2 into 2 into 2. So actually the prime factorization of 16 is this. You multiply all of them, you will get the answer as 16. So 16, when expressed as the product of prime factors, we say we have done the prime factorization of 16. Let's just see some examples. As you can see here, 36 is there. Okay, so 36 can be written as 2 into 18. 36 can be written as 3 into 12. 36 can also be written as 4 into 9, and as well 6 into 6. Okay, see, what we are going to teach you now is that prime factorization is unique. Whatever you solve with, like whatever factors you write, first of all we have written 2 into 18, which are two factors of 36. Next we have written 3 and 12, those are another factors of 36. 4 and 9 are two different factors of 36, and 6 and 6 we have written. So whenever we are going to solve them, we are going to convert them to prime factors, the answer is always going to be unique. Just see, 2 is a prime number written as it is. 18 can be written as 2 into 9. Okay, now this 2 as it is has been copied. 9 can be converted to 3 into 3. Yes, so 2 and 3 both are prime numbers. So we have actually expressed 36 as 2 times 2 and 2 times 3. Okay, in case we solve this, 12 can be written as 3 into 4. 4 can be written as 2 into 2, because 4 is not a prime number. We have to get the prime numbers only. So 3 and 2 are prime numbers. See, this is same, 2 times 2 and 2 times 3. Similarly, when you do this, we know neither 4 neither nor 9 is a prime number. So 4, when converted to prime factors, can be written as 2 into 2. 9 can also be written as 3 into 3. So 2 times 2 and 2 times 3 again we are getting, as you can see here. Similarly, 6 into 6, 6 can be written as 2 into 3 and 2 into 3. So again 2 times 2 and 2 times 3 we are going to get. So the prime factorization is always unique. You need to understand this. So what we have to basically write, we can write 36 for the given number as product of any two numbers, and then slowly we can convert them to prime factors. So what is prime factorization? When any number is expressed as the product of its prime factors, then we say we have done prime factorization of that number. So let's just do this activity. Choose a number and write it. So think of a factor pair, say 90. 90 is there. If I think of the factor pair, that is 10 into 9. If I think of 10, then 2 into 5 suppose are the two factors. Let's try to convert them to prime factors. See, first of all, the number is 90. If the number is 90, I will write like this. Actually, basically, we are discussing factor tree here. How does that tree gets formed? That I am teaching you. So 90 can be written as how? 10 and 9. Okay. Can I break down 10 now? Yes, I can write it as 2 and 5, because 2 into 5 will give me 10. So this is how we write. And 9 can be converted to 3 and 3. So actually, the prime factorization of 90 is 2 into 3 into 3 into 5. So this, you see, 2, 3 and 5. All three of them are prime numbers. So this is how we form the factor tree and we do the prime factorization of 90. This is one way. we have one more way of solving it that we will also be discussing. So these are the prime factors that we have calculated for 90. Now we have one question here that we have to find the prime factorization of 980. How do we do it? First of all, the prime factors start with 2. It is 2, 3, 5, 7, 11, 13 like this. Yes, we already have discussed prime numbers. What are prime numbers? The numbers which are either divisible by 1 and itself. The numbers which are having two factors only, the number itself and 1. Those are prime numbers. So first of all, 980, we start with the smallest prime number. Let us see, is 980 an even number? Yes, it will be divisible by 2. Dividing it with 2, let's divide. I'll write 2 fours are 8, 1 is left, it will become 18. 2 nines are 18 and 0. Clear? So I have divided 980 with 2. Again, I see I am getting an even number. Let's again divide it. So 2 twos are 4, then 9 is there, so we will divide with 4, like 2 fours are 8. Okay, so I'll write 4 here, and then 1 is left, so it will become 10. So 2 fives are 10. Now it is 245. It will not be divisible by 2 because it is an odd number. Let's try with 3. Can we divide it with 3? No. 245 is not divisible by, exactly not divisible by 3. Okay, see, 245 is there. If I divide, 3 eights are 24 and I copy down 5, so 3 ones are 3. I will be left with 2 remainder. It is not exactly divisible. Let us start with 5. Okay, 5 fours are 20, 4 is left, 4 along with 5 makes 45, 5 nines are 45. Now I know 49 is divisible by 7, so 7 sevens are 49. Okay, so now you have to try unless and until you get 1. So 980, how can I write it as the product of prime factors? So if I have to do the prime factorization, it means I have to write it as the product of its prime factors. So 980 would be equal to 2 into 2, whatever the values you are getting here, you have to multiply. 2 into 2 into 5 into 7 into 7. So we have to write them as the product. When you multiply all of these, you will get 980. So this is how we find out the prime factorization of 980. You could do it using the factor 3. Like you could write it as 98 into 10. Okay, then you had to write 98 as 49 and 2 you can write. This you can write as 2 and 5 because 2 into 5 will give you 10. Then 49 is 7 into 7. 2 is prime, so we don't have to do anything with it. And the rest 2 and 5, these are also prime. You see, what are 2 times 7 we are getting, 2 times 2 we are getting, and 1 times 5 we are getting. So these are what? The prime factors of 980, and we have expressed 980 as the product of its prime numbers, or I say prime factors. So this is what the prime factorization of 980.